Hello, dear friends. In this video, we are going to see about vectors on the basis of RAG. So, in the previous video, we saw what is RAG and how the RAG is working and how the RAG is contributing in developing the chatbot. All these things we saw with an example in the previous video. So, in this video, we are going to see about vectors and how the vector is working with an example in the concept of RAG. So we know that vector is nothing but it is a numerical representation for any text because the computers doesn't understand the text. It can understand like a numerical representation, more particularly zeros and ones. So it is better idea to convert the text in the form of a number, so that we call it as vector. So this vector can be given as a representation for the text. So why we want this vector representation, that is the numerical format is, so it will be ease our work in finding the other similar words. So similar meanings have similar vector. For example, if I want to match, so here is an example. You consider AI is powerful. That is one particular phrase. Another one is artificial intelligence and is strong. So if you see generally, we couldn't able to see the similar words in between these two. So if you search something based on words, we think that this both are not similar. We may be thinking that both are different, but if we have a vector for both, then we can understand the vector will have the meaning of the particular text. So if I have the vector for this AI is powerful, and if I have the vector which means the numerical representation of this both phrase, then I can easily find that this both phrases are similar to one another. So vectors are close. And if you see in this example, AI is powerful and banana is yellow. So this both phrases are not close to each other. They are not. They are far away from each other. So the vectors are far. So how we can easily find is when we have a numerical representation based on its semantic meaning, we can easily find even though the words are not most similar to each other, we can find meaningfully or semantically they are close to each other. So that we can find it very easily because of this vector concept. That's why we have this vectors. And then embedding. Embedding means this process of converting text to numerical form, we call it as embedding. So it converts the content, it can be a text or an image, whatever it may be, we can have a vector representation of that, which means it has some list of numbers which represents the meaning of that particular text or image or whatever it may be. So this vector captures the meaning, the semantic information of that particular input, maybe in the form of a text, or the input may be in the form of a image or a video or whatever it may be. So vector embedding means it's created using embedding models. We have lot of embedding models already available. In the previous example also, we saw one sentence transformer embedding model which convert our text to a numerical representation. So each sentence will be having one vector. So it is some series of numbers will be there, which represents the meaning of that particular sentence. So this vector will be stored in a vector database. So we will discuss about this in the next video. So why vectors are important? As I discussed earlier in the previous example, it will be helping us to search anything faster, and also we can do searching not only keyword based, but we can do meaningfully, we can do a search. So we call it as semantic matching, that is meaning based match. So better than the keyword search, meaning based search. So if you see in this example, if you search by keyword, then we won't say that both are similar, but meaningfully if you search then these two phrases are close to each other. So that is the purpose of vectors. And how this vectors embedding work is the, so every words have a numerical representation. Then it can be plotted in a multi-dimensional vector space. So whichever words are close to each other will be having minimal distance between them. And if the if the words are not close to each other, then the distance will be far. So by that we can understand that these two are similar to each other or not. So the distance between two similar vectors are less, means then we can say the two phrases are the vectors are close to each other in their meaning. So, for example, if you see here, if it is far, the distance is far means then we can understand that these two phrases are far from each other. So here is an example: cat and dog are closer to each other because they both belongs to the category of animal. But if you consider cat with computer, the distance will be far because they are not meaningfully similar. So here is a simple example. For example, if we represent this cat with a vector of this kind and the dog with this kind, if you match each and every numbers, they are almost close to each other. So we can understand they are close to each other. So this is a simple example. So there are many methods are available to create this embedding. So what is embedding? Text embedding means already we saw the process of converting this, the method of converting this text into vector, we call it as embedding. So there are three important methods. One is bag of words method that we call it as count vectors. So it counts how many times each word appear, and but now so it will not understand the meaning or the word order. That is the word order is also very important. Sometimes two phrases may be having exactly same words but in different order, convey different meaning. So bag of word doesn't consider that. So that is one method. Another method is word to vector. So this is another method to do the embedding, which means converting the text to numbers. So here it learns a word and it finds the relationship between the words by predicting the nearby words. So it captures the new semantic meaning better than the bag of words. So here it will not understand the meaning bag of words, but here it understands the semantic meaning. So that's what's so important, right? Rather than understanding the meaning based on the keyword search, if you understand the words based on semantic, that is meaningful match, it is a better idea. The next method to do this embedding is transformer based model. This is a very modern approach. So it understand the context. You might have heard about attention model in the transform. So it will understand the context and the word order, and also capture its complex relationship so that it will understand the whole context very well. So it is trained on very large data sets. So these are some of the categories of methods which help us to do the embedding. So first is image embedding. So it's created using edge detection, texture analysis, color features. So based on all these features, this image embedding is done. So the modern system use this pre-trained CNN models like ImageNet to generate this embedding. The CNN outputs a vector that represents the image important features. So all the important features of image will be in the form of vectors. That is a numerical format. And the next one is if we have the vector for a particular phrase, which means the numbers, then arithmetic operations can also be done. So that is another interesting one. So embedding allow mathematical operation. For example, if I want to get a queen, so I can do like this: king minus man plus women will give the queen. So this is how I can derive so many things using this kind of arithmetic operations. So this shows that the embedding capture meaningful relationship as well. So that is the power of vectors. So why this embeddings are useful? Which means why this kind of numerical representation are useful means it measures, as we discussed, the similarity in a very easier manner, meaningful manner, and searching also it will give a meaningful search. It is very useful in the field like recommendation system, and also it helps us to do the document classification, sentiment analysis, and all these things, which means to review set phrases, whether it is a positive comment or a negative comment. This kind of analysis can also be done because of this embedding, because all the text or in the form of numerical format. So, or the image can be in the form of numerical format. So, doing arithmetic operation, understanding all these things can be easily done. So, let us, before we go to the examples, so here is a matrix which shows the distance between cat and cat is very zero, right? Similar. Cat and dog, the similarity is 0.5. Similarly, you can find the difference. The next one is vector search. So since we have the vectors, the numerical representations, search is also very important. Every data item is in the numerical format. So searching anything will be in the form of a list of numbers. Actually, the vectors are in the form of list of numbers. So searching is very easy. So this vector acts like a coordinate, as I showed in the previous slides. It's like a in a high dimension space, we can plot it and we can find the similar items. We can compare the query vectors with all other stored vectors, so you can easily do it, do any kind of search. So this kind of similarity search can also be done using some of the measures like cosine similarity, Euclidean distance, dot product. Since the vectors are plotted in a high dimensional space, we can easily find the similarity between them, even in the form of cosine similarity or Euclidean distance or dot product. We can easily find the distance. The next one is vector storage. So this vector storage we will be discussing in the next video. So before that, let me show you the demo for the vectors. So here is an example, as I have already explained in other videos also. So first we want to import the necessary the library files required. So here we are from LangChain. We are going to install the sentence transformer and and all the necessary things. And then already I have told you the previous video, Grok API key is used to access the LLMs available in the cloud, so which is available freely. Now from the LangChain, I am using from the LangChain community embedding, we are going to use Hugging Face embedding. Other embeddings are also available. So in this example, we are going to use the Hugging Face embedding. And for that, we are creating an object for that. So the model we are going to use is from the sentence transformer, we are going to use all mini LM L6v2 model. So this model helps us to just do the embedding, which means what? Converting the text into numerical format. So here I'm going to give input dog as an animal. So using this object embedding, I say embedding dot embed query. What we have to embed now? This query. Dog is in. So this will be in a numerical format in this variable now vector. So vector have this. Now we let us display what is the length of this vector, as well as we are going to see the first 5 values of the vector. Actually, if you see it, actually the total length of the vector is 384, which means this dog is an animal is represented in 384 values in the form of a vector. Let us see the first 5 values. That's what we have taken from this vector. We are going to take the first 5 values. From the starting value, the first 5 values. So here is a numerical representation of dog as an animal. So the first 5 values are displayed here. So this is how we can see the vector. You can, if you want, you can likewise get the vector of all these things. So for any input sentence, we can do it. So this sentence transformer, that is all mini LM L6v2, help us to convert sentence into a vector. It's a free model and it is widely used in the RAG applications. In the previous example video, we have explained all this RAG also. So first, using this Grok, I'm going to use an LLM, that is Llama. And now I'm going to use this LLM. So which LLM we are using? Llama model, that is 3.18b instant. So using this object, we are going to use this invoke function. What is the purpose of invoke function? It helps us to give the input and help us to get the response back. So I'm going to ask, explain what is machine learning. So this input will be given to the LLM. So that response is now stored in this response. So here this is not related to vector. Here I'm just explaining how an LLM is getting an input, and from this response, we are going to take only the content, because response will be getting all kinds of response, including the metadata. From that, I want only the content. So that this is what it is giving us an example. Now let us see embeddings. That's what the important thing here in this video, right? Embedding plus LLM together. So I have two texts. So the dog is a pet animal and cat is a domestic animal. So these are the two input text. So both the things are going to be embedding. We are going to do the embedding. So text one, both are embedded. So using this embedding model. So here we have already have an embedding model, right? Using this embedding, using embed query, we are going to get the embeddings of these two phrases, that is in vector 1 and vector 2. Now what we are going to do, we are going to use the cosine similarity to find the embedding, that is the similarity between the vector 1 and vector 2. This is the formula for that. And then we are going to find a similarity. So the similarity between these two phrases, dog is a pet animal and the cat is a domestic animal, the similarity is 0.5406. So this is a similarity. So this is what a vector is. And now we are going to use LLM. So we are there. We are going to give this two inputs, text one and text two, and we are going to get the explanation of this using this LLM. So we will be understanding here. I am asking explain why text one and text two are similar. So our LLM is going to answer for it, and from the explanation we are going to display the content. So here we have the full meaning of why it is similar. So from this you can understand how the vector when a given input is given, it is converted to a numerical representation, and we can check the value. So how it is similar in the numerical format, so that it will help us to do any searching recommendation systems in all these places. It will be very useful for us to get a meaningful and faster response. Hope you have understood. Thank you. God bless you.